Hello everyone and welcome to the first code walkthrough. This is the code walkthrough of session 1. We're gonna do one of these for every single one of the sessions, and the goal is for me to show you the end-to-end machine learning pipeline that we're gonna be building throughout the program. My goal with these videos is for you to understand exactly what I'm doing, how am I accomplishing it, and why I'm doing every one of those things. So let me start by showing you this diagram here. And this is the diagram of the system that we're putting together. Specifically, this is the training pipeline. And you probably saw this already during session 1. And the training pipeline for today, we're just gonna be focusing on the first step, the one that's called split and transform step right here in the diagram. And there are gonna be 3 things that matter for today. The first one is that our data, the data that we're gonna be processing, is gonna be coming from an S3 bucket. It's right here on your left. That S3 bucket is a location in AWS S3 where we store data. We're gonna be taking that data, sending it to a processing job. And that processing job, it's basically a job that's gonna be running in AWS. That job has the sort of like the goal of splitting the data into 3 sets. We're gonna be using a training set, a validation set, and a test set. And it's going to be transforming each one of those sets. And the output of the job is gonna get stored back into S3 to a location that I'm calling here dataset splits. These 3 sort of like components, they're not components, it's just actually one component plus S3, but these 3 drawings here are the ones that we're gonna be covering today. Okay, so let's go now to the code, and here is my Visual Studio Code. I'm gonna be running all of these sessions locally on my computer. So basically I'm gonna be using Visual Studio Code to access the notebook of the cohort and running that notebook here. So I'm gonna show you exactly going step by step of everything that you have to do. Today we're just gonna be seeing the content of session 1. You can also follow along by going to the program.ml school website. And when you go there, you're gonna see here on your left, it says building production machine learning systems. That is the cohort informed in the form of documentation. So you can follow along. You get here every single session with all of the steps, etc. You can follow along just by going to this website. And sometimes we're just gonna switch here to the website because it's easier here to explain and to see things rather than doing them in Visual Studio Code. Something very, very important. You should have at this point, but if not, you should do it now. You should have at this point gone through the setup instructions. The setup instructions are right here. So you can see them right here in the website. This will help you get your environment ready. Here is the thing. We want to run everything from our local environment. That means that we have to configure our local computers to get access to SageMaker, right? Because we could sort of like bypass most of this configuration if we wanted to run everything from inside SageMaker, but that will take a lot more work later. It's more cumbersome. You don't have access to your own environment and your own tools. You cannot use Copilot there. So if you want to run from your local computer, and I recommend you do, you have to go through these setup instructions. It's very, very important you do so before jumping into the cohort because nothing will work if you do. All right, so let's go back to the code and let's start going down the list. So the first section here that you are going to see in the code, it's called initial setup, okay? And the initial setup is basically when I'm getting ready to run this notebook. And I'm gonna try to go here and give you sort of like the important details. So first, I'm going to create 2 folders, and one of them is called code. So you're gonna see that code folder within your local environment after you run this cell. I'm gonna create that folder because I'm gonna be generating scripts and I'm gonna be saving all of those scripts in that folder, right? I'm gonna be creating two of these folders, code and inference, which will go inside code. And we will talk about that one, I think it's in session 4 or session 5. And then after doing that, I'm gonna be adding the path to those folders to the sys path. This is what you do whenever you want Python to look into one of those folders to import a library, a class, a function from one of those files. So I'm just making my scripts available to the Python interpreter so it can load those files in memory and I can execute them or run them from inside the notebook. And I'm going to show you why exactly I'm doing that, where, and I'm doing it just for testing those files. So we'll get there. After that, I'm just creating a constant, and that constant is just pointing to the data set that I have locally here. I'm configuring an extension that I installed. It's called IPyTest. It's pretty cool, something that I discovered recently. It allows me to run PyTest unit tests right from a notebook, and that's pretty awesome. I think it's a great idea, and I've been using it a lot since then. Finally, I'm configuring the level of logging from the SageMaker SDK, just so it logs only error and above, so errors only, because it's very verbose. I'm just preventing the notebook from getting just swamped by irrelevant log messages. Okay, so after that, we see the definition of local mode here. It's a constant, is very, very important. So here's the thing. SageMaker supports local mode. And local mode is nothing else than the ability to simulate the cloud in your computer. So basically, we can run processing jobs, for example, right in your computer without ever hitting the cloud. Why is this cool? Well, first of all, you don't spend any money because you're running everything on your computer. Second of all, it's really fast, right? You don't have to provision an environment in the cloud. You don't have to wait for the image to get installed, which is usually slower. You can run everything right here on your computer. The downside, however, is that not every step of the pipeline that we're going to use is supported locally. So for today's session, we do support the processing job. That's the one that we're going to be creating today. That one we can run locally, which is awesome. But some of the jobs that we are going to see in future sessions are not supported locally. For example, we're going to be doing in session 2, we're going to be doing hyperparameter tuning, and hyperparameter tuning is not supported locally. So we will only be able to test that up there in the cloud. So we'll see there when we get, we'll see that when we get there. For today, I'm going to set this variable to true, meaning when I execute the pipeline right now by setting this variable to true, that pipeline will run locally. And after we do that, I'm going to set it back to false, and I'm going to show you the pipeline running in SageMaker. When I set it to false, it's going to run in the cloud. So again, for now, that's true. That's awesome. After that, I'm going to be reading a couple of variables from my environment variables. And one is bucket and one is role. You should have those two variables set already. If you followed the setup instructions, one of the steps that you have to go through is creating this environment file. You can see it here. It's called .env. And if you open that file, you'll see that I have bucket right there. I have another two properties, and then I have the role. And this is a role with permissions. You set the permissions during the setup instructions for this role. So it has access to, spinning, processing jobs in SageMaker and doing all of the stuff that we need to do. So obviously, if you went through the setup instructions, you should be all set. You should have those two variables set already, and this cell here is just loading those variables in memory because we're going to use those values. Okay, next line here is an interesting weird trick that I'm doing here. Here is what's happening. SageMaker does not support, when running in local mode, SageMaker does not have an out-of-the-box Docker image to run TensorFlow in your computer. If you're running on Linux, or if you're running on a Windows computer or on any Intel processor, you're all set. You don't have to worry about this. But if you have an Apple M series chip, SageMaker does not have a container ready for you. So I had to create one because I'm running everything here. What you see here is an Apple M2 computer. So actually, this is an M1 computer. So I had to create a Docker container with TensorFlow support that runs on my Apple M1 computer. So if you have a Mac, when you went through the setup instructions, there is a section there that you need to go and create a Docker image. Okay, this cell that you're seeing here is basically initializing a constant that is going to tell the rest of the notebook whether you are running on an Apple computer to basically use the Docker container that you created during the setup instruction or not. And you'll see that immediately when I'm using the is Apple M ship constant. One thing to notice for those of you who are new to Jupyter Notebooks, this here is a bash command, which is super awesome, that I can put on the same line Python, which is up to this point here. This is Python code, and this is a bash command. And I can basically run a bash command and assign the result to a Python variable. And that is pretty awesome. And I know it's a bash command because this symbol here, basically you use that symbol in a notebook just to indicate, hey, I'm gonna be running a command. I think that's pretty awesome that I can combine those two things together. Yeah, that's thanks to Jupyter there. Okay, so here is the configuration that I was talking about before. I'm gonna be creating a config dictionary. And this is just a config that's gonna contain a bunch of settings that I'm gonna be using throughout the rest of the notebook. And I want to initialize these settings based on whether you're running in local mode or not, right? That's basically what I'm doing. That's why you have here sort of like the question, if local mode is true, then set these variables in the config. If not, set these variables. So let's go one by one, just to make sure you understand what every one of those variables does. So first is the session. Every step of our pipelines will need a session. And here, if it's in local mode, we're going to be using an instance of local pipeline session. And if it's not in local mode, we're going to use an instance of pipeline session. You can see it here. The reason I define this as a variable is because somewhere down below, I'm referencing that variable directly. So I needed it outside of the config. But anyway, it doesn't matter. It's basically we're gonna be using a local pipeline session if you're running locally. That's sort of like what tells SageMaker to simulate everything on your computer, or I'm gonna be using a pipeline session if we're running in SageMaker. Instance type. This second variable is how we specify the computing hardware that we want SageMaker to provision to run any processing job, any training job, basically any cloud job that we want, right? And for most of the steps, I'm going to be using an ML M5 X large job. Hardware. This indicates how much memory I need, whether or not I need GPUs, which by the way, I don't need GPUs for an M5 X large. How many virtual CPUs do I have? So this is sort of like a unique identifier that's going to tell AWS, and in this case, SageMaker, this is sort of like the computing hardware that I need, right, for you to provision. Notice that if I'm running in local mode, it's local because I don't need anything here. But if I'm running in not local mode, if I'm running in the cloud, I'm going to be using that ML M5 X large. why am I using this one here? And can you change it to a different value? So first, can you change it? Yes, you can put whatever you want here. It really depends on the job that you're running. If it requires more memory, for example, you're gonna have to change it to something with more memory. You can look at the list. You can Google it and you can get a list of all of the available instances, and they will tell you how much memory each instance has, etc. I recommend the ML M5X Large because it's fast enough for what we are doing and it accommodates everything that we need for this pipeline. But if you make changes to that pipeline, if you try to, for example, load a very large data set, this might not have enough memory for your data set. You're going to have to change it. Also keep in mind that the ML M5X Large gives you 50 free hours every month. Not every month, I'm sorry. So when you create an account, it will give you 50 hours for free, okay? Which is awesome because that means that you can run this pipeline hundreds of times before you ever hit that maximum number of free hours, which is, I mean, you're gonna run all of this for free for sure. The downside, however, is that by default, a new AWS account does not have access to these instances. Basically, AWS gives you a quota of 0 instances. Why do they do this? Well, to protect themselves from people who come to AWS, run an example application, rack up a bunch of hours, and they have no idea that they're going to get charged at the end of the month. So when the month comes in, the new month comes in, and AWS sends people a bill, they are like, oh, I'm sorry, I did not know. And you did not tell me that that was going to cost me money. And they have to roll back all of those charges. And this is a constant thing that happens. So to protect against that, AWS says, you know what? You're going to have to manually request access to those instances. So they give you access to the very, very cheap instances that we cannot even use here because they just are either too slow or they don't have enough memory for us to run a TensorFlow, etc. So they give you access to those, but they don't give you access to this one here. So part of the setup instructions is to request a quota increase. It's free. You don't have to do anything. You just have to go to their website and ask the team at AWS, hey, can you please give me access to 3 or 5 of these instances? You should have done that by now if you went through the setup instructions. If not, you want to do that as soon as possible because you will usually get access in 24 hours to those instances, but sometimes it might take 2, 3, 4 days for the AWS team to give you access to them. So just do that as soon as possible so you can actually run the pipeline. All right, let me get a sip of my drink here. Okay, so the other 3 variables here are related. And they are how we tell SageMaker what specific instances or container images, we are going to be downloading and installing in the jobs that we run in the cloud, okay? I told you before that the Apple M series computers did not have access to default images, a default image to run TensorFlow. So we had to create one. If you were running on an Apple computer, if you are running on an Apple M1, M2, or now M3 computer, you need to sort of like create one Docker image. So that's what you see right here. So if you're in local mode and you're running on an Apple chip, we're going to be using this Docker image, which happens to be the same name you used when you created that image as part of the setup instructions. Okay, so that will only happen in local mode, obviously, and only if you're running on an Apple M chip. If not, I'm specifying that the image is going to be none. Why is it going to be none? Because SageMaker will determine what image to install depending on the framework that you use, and you'll see how you specify the framework, the version of that framework, and the Python version. Those are the other two variables. So notice here that the framework version and Python version are right here, and you will see when we define a processing step how we use those two variables. But pretty much the framework version is going to be 2.11 because this is only for the TensorFlow specific container. We're going to be using version 2.11 of TensorFlow. That's why I specified 2.11 here, 2.11, and Python 3.9. That's the only option available. So SageMaker, at the time that we train a job, which is when we are going to be, or at the time that we train a model, and we need to run a training job, SageMaker will use a combination of the image, framework version, Python version, and the class that you use to set up that training step to determine which image it should download and install on the container. That's what this config is going to do for us. Okay, so finally, and we're done with the setup portion of this, I get a bunch of variables here that I'm going to be using throughout the notebook. I'm just defining them here so I can use them later. I don't have to redefine them later. And just want you to notice the Boto 3 reference here. The Boto 3 reference. Boto 3 is AWS's API to their entire ecosystem of tools. So just using Boto 3, I can access anything in AWS. So you can see that I'm creating two clients. I'm creating first a client for SageMaker, so I can access SageMaker directly. And we're not going to be using this variable today, but we're going to use them in future sessions. And I'm creating a client to IAM, which is their permissions, authentication, security, sort of like service. We're going to be using that in session 3 or 4, I think. Okay, so this puts the setup out of the way, and we can get into the good stuff, which is session 1. So session 1 here, again, this is sort of like the diagram of the whole training pipeline. Remember, we're only going to be focusing on these three, the portion here, right? So the data that's coming from S3, going into the processing job, coming out into the dataset splits here, or S3. That's where we're going to be sort of like spitting out the output of the processing job. I created one step here. The first step of the notebook is called exploratory data analysis. Okay, so this has nothing to do with the pipeline. This is just a section that I created to show you the process that I go through in order for me to understand the data that I'm working with a little bit better. So I added a bunch of steps that they vary obviously from problem to problem, but I wanted to show you, to give you a taste of what those look like whenever I'm trying to understand what is this data, right? And why does it look like this? Well, I go through these steps here. So I'm gonna go really fast through these steps. Again, this is for you if you don't have experience with data analysis. You should take a look at this. You should ask questions about every one of these steps, just to give you an idea of what the Penguins data looks like. Okay, so first of all, I'm reading the data in memory, and I'm displaying the first 5 columns, okay? Of the data, that's what the head here does. Something interesting for those of you who are not, or this is your first time dealing with Jupyter Notebooks, you will notice that this calling head here, I don't have to print it, but the Jupyter Notebook is automatically printing the result of the last line. So if I come here and I say 1 plus 2, and I rerun this cell, I'm gonna do that with Shift return. When I run this cell, you'll see that now it's printing out 3, because it's automatically printing whatever the result of the last statement in that cell is. So in this case, it's 1 plus 2. If I wanted to print head now, I will have to do a print here. So now if I do that, I'm gonna get both of those results. First, I'm gonna get the result of head, and then I'm gonna get the 3 because it will be automatically printed. So that's something just to keep in mind. For those of you who are new with Jupyter Notebooks, that's what's going on here. So anyway, here is our data. Head is going to return the first 5 rows of that data set. And here we have the species, we have the island where that particular penguin comes from, the length of the colmen in millimeters, the depth of the colmen in millimeters, the flipper length, the body mass, and the sex of the penguin. Those are the columns that we're working with. Obviously, the target column, the column that we want to predict, is going to be species. So given the rest of the data, given the island, the colmen, the flipper, the body mass, the sex, we want to predict the species of that penguin. It's gonna be a multi-class classification problem. Multi-class because there are multiple classes. There are gonna be 3 species of penguins. So more than 2 classes makes the problem a multi-class classification. If we only had 2 classes, this will be a binary classification problem because it's either one or the other. It's binary. In this case, it's gonna be a multi-class classification problem. Notice as well that there are missing values. Like for example, just in the top 5 rows, we have here not a number. That's what none means, right? So it's a missing value. There's no value for that. We're gonna have to handle that. We saw that in the first session about imputing missing values. We're gonna have to handle that here. It's the same thing across the board for this. This is a very bad row there. We don't have any values. We only have that is Adelie and that we captured that information in that island, but that's it. Okay, so here is a quick explanation about what's going on in that column. One thing that's important for you to keep in mind as you are navigating through this cohort is that I took the time to write a lot of explanations about every single cell in this notebook. So you're gonna get as detailed as I thought it was necessary, explanations about what's going on every cell. Sometimes I've gotten questions, which is great. Just please keep asking questions, but sometimes you get questions about one particular cell and the explanation is right there next to the cell. But we are sort of like trained not to read and just look at the code, but just make sure you take a look at the sort of like the explanation because I'm trying to sort of like guide you through the code. So I added this image here because I found that online with the creator of the top penguins image, which is I think is beautiful, Alison Horst. And this is sort of like an explanation of what a colmen is, just in case for those of you who don't know what a colmen is. I didn't know for sure. So this is the colmen length here, and this will be the colmen depth. That's how you measure it. Okay, so let's see what's going on here. All right, so let me take a sip. So here I'm describing the whole data set, including all of the columns. And here you get important information about the data. Again, how many samples do you have for every column? How many unique values? That is something that's interesting here. So I have 3 species, 3 islands, Torgerson, Bisco, and Dream. Sorry, Bisco is an island? I don't remember. Yes, Bisco is an island. So 3 islands. Notice that I have 3 sexes here. See, 3 sex. We're gonna have to see what that is about. So I'm gonna be printing out here the distribution of every one of my categorical columns. I have 3 categorical columns. In other words, columns that are not numeric. And I'm gonna print the distribution of those, just basically saying, hey, just display the value counts of each one of these. So here we have the species. We have Adelie, Gentoo, and Chinstrap. And here you get how many samples we have for each one of those species. Here we have the islands, Bisco, Dream, and Torgerson. And here you have how many samples you have. And then you have sex. And we have 168 male penguins, 165 female penguins, and one penguin that's a period. I'm guessing the scientists did not know what this penguin was, that or they just made a mistake. So we're gonna have to fix that, obviously. And the way to fix that is it's very simple. I'm gonna grab penguins, the sex, that column, and I'm gonna replace any period with just not a number. So I'm gonna just basically turn that value into a not a number so we can later handle it. So yeah, after I run the value counts again, now it's 168 and 165, which is the same value that we had before, but there is no period anymore, which is what we wanted to do. Okay, so let's now handle the not a number values, the missing values. So this here displays the sum of every value per column that is null. So you see here that we have 2 null Coleman length, 2 null Coleman depth, 2 flipper length, 2 body mass, and 11 values in the sex column that are missing. So we're gonna handle them, and this is how I'm gonna be handling them. And again, we're gonna have to do that as part of our script, of our actual pipeline. I'm doing it here just to clean up the data so I can visualize it, I can make it better. But yeah, that's what I'm doing here. I'm basically replacing every missing value with the most frequent value in that column. That's sort of like the strategy that I'm using to replace missing values, to impute values that are missing. So it's a simple imputer, and the strategy is the most frequent. And after I do that, and I run the sum again of null values, you'll see that it's now 0. So I've replaced every missing value. Awesome. All right. What's going to happen right now is that I'm going to display a bunch of charts. So I'm using Matplotlib here just to display a bunch of charts that I want you again to pay attention to sort of like look at the data, get a feeling for it, try to understand what's going on. That's what's going to happen right now. So first I have a chart for the distribution of species, distribution of island, and distribution of sex. Then I'm going to display the distribution of numerical columns. And here you get the charts. Then this is kind of important. I'm going to display the covariance matrix and the correlation matrix. And what is important about this, I'm not going to get into the science behind these matrices, but what I want you to do is make sure you read the comments next to each one of these cells, because I'm going to make some assumptions. I'm going to read the results and I'm going to interpret those results and make some assumptions based on what I'm seeing. So for example, penguins that weight more tend to have a larger Coleman. So that is an assumption that I'm making by looking at the covariance matrix. So usually the larger the Coleman, the more the penguin will weight, which makes sense. Let's see another one and then we move on. The more a penguin weights, the shallower its Coleman tends to be, which is interesting. I was not expecting that. So the heavier the penguin is, the shallower the Coleman will tend to be. That is another conclusion that I can get out of the covariance matrix. Same thing with the correlation matrix. I'm doing the same thing, but now it's the correlation matrix. I have a quick explanation of what correlation measures, and I have a few conclusions that I'm getting out of this correlation matrix. Again, just take a look at it, just so you get a good feeling about what's going on here. Then I'm going to be displaying 2 more charts. One is the distribution of species by island. It's going to show me where species are distributed across the different islands. And then one is the distribution of species by sex, which is going to show me how those, different sexes are distributed across different islands. How the different species are distributed across the different sexes. So basically I can look at it and see that they are almost equally distributed. So you have the same number of adelie that are male than female, and the same number, well, actually it's a little bit more gentoos that are male than gentoos that are female. And then you have chinstrap, The colors are all messed up here. The colors are kind of weird because I'm using transparent colors. So I'm not sure which one is Chinstrap or Gentoo. I'm going to say Gentoo is the green one, which is the middle one. Chinstrap should be the bottom one. And those are sort of like roughly equal distributed between male and female. Okay, so that is sort of like the exploratory data analysis. Again, this is for you to take a look at the data. You can add more to it. You can try to understand what's going on. And that's very important. Whenever you face a new problem that you need to understand, that you want to understand what's happening. Okay, let's get into the cool stuff. And that is the creation of the processing script. That will be step number 2. So now we're going to start preparing. Go back here to my browser. We're going to start preparing this processing job. And what a processing job is basically SageMaker creating a job that's going to run in the cloud. But that job will run code. We need to provide that code. And that is what the processing script is. So that's what I'm going to create right now. I'm basically creating the script that I want SageMaker to run in the cloud. That's what's going to happen in this step number 2. Something important. Notice that I'm using, at the beginning of this cell, I'm using a cell magic, and I call it cell magic because it starts with this symbol twice, so the percent symbol twice. That's how you reference a cell magic. That's something that Jupyter Notebooks use. And this cell magic is write file. What this is going to do is it's not going to run the code that's in here. So I'm not asking, when I execute this cell, I'm not telling my notebook to run this code. Instead, what the notebook is going to do is create a file, is write all of this into a file that's going to be within the code folder, and it's going to be called preprocessor.py. Now, why is this relevant? So a bunch of people look at me using a Jupyter Notebook for everything that we're doing here in class, and they ask me, hey, do you also use Jupyter Notebooks in production? I've heard that you shouldn't use Jupyter Notebooks in production. And that's, I think, is a misunderstanding of what a Jupyter Notebook is and how you should use them. Like here, a Jupyter Notebook is basically the door, is the interface that I'm using to create every resource that I'm going to be running in the cloud, especially the scripts. Like it's the same thing. It will be the same thing if I sort of like create a new file and type out every single line of the script, just write a regular Python script. Instead of doing that, I'm just writing my script as part of a cell, and this cell is going to create that physical script, physical file in my hard drive, and I can reference that file later. That's what I'm doing here. I just happen to do it as part of the whole notebook, so I don't have to be jumping back and forth from my notebook to the script. So just keep in mind, when you run this cell, nothing is running. You're just creating this file within the code folder. So I already run this obviously locally, but when you do this, you will have a code folder that you created before. And inside that code folder, you're going to get that preprocessor file, which is this one here. And this is just a regular Python script. You can see here, it's just a regular Python script. Okay, cool. So let's try to go line by line. First, you're going to see these weird looking comments. I'm not going to get into these too much, but these comments are for MBDev. So I want you to, especially if you have a lot of experience with Jupyter Notebooks, I want you to look at MBDev. This is awesome. It brings a ton of cool features to Jupyter Notebooks, including the ability to automatically turn a Jupyter Notebook into documentation. That's what I'm doing right here. That's this web page that you see here. This is exactly the same file that I'm showing you, the same notebook. It's just MBDev is turning it automatically into documentation. So using those commands, I can specify stuff to MBDev, how I want this documentation to look like. Like, for example, I'm asking MBDev to name this preprocessor in the documentation. So if I go to session 1, step number 2, this name right here, it's coming from MBDev creating that name right here because I'm specifying it to do so. You see the line numbers here? They are there because I'm saying code line numbers true. Okay, so that's why it's displaying the line numbers for this script here. So again, it's anytime you see command symbol, so pound symbol, and then this pipe symbol here, that's an MBDev command. So let's go through the script now, which is pretty straightforward. Again, remember you have to sort of like keep in mind who's going to be running this file. It's going to be running in the cloud. SageMaker is going to make available to this file an input folder, and you'll see later how to configure that input folder. And it's going to make available an output folder where the file should write anything that wants to output. And that's the way SageMaker is going to run this script. So we can assume that SageMaker is going to give us sort of like a base directory where everything is going to happen from that point on. And again, the goal of this script will be to load input files, split those input files will be CSV files or basically data. We're going to load them in memory. We're going to split them and we're going to transform it. And then we're going to spit out all of those splits. So spit out, what I mean by that is save them into the output folder so SageMaker can send those outputs to S3. So this is the entry point of the script, is preprocess, okay? So this is what SageMaker is going to call. I know that because it's, if you go down the script, that's sort of like the main section here. So the script, when SageMaker executes this script, I'm calling preprocess here. That's it. That's what I'm calling. Notice that this is the path of the base directory. In every processing job, that is the path of the base directory. That's what SageMaker makes available to me. Cool. So let's go back here. Preprocess. First thing that's going to happen is I'm going to call this function. I'm going to show you now this function. It's read data from input CSV files. So without even looking at the function, what I'm trying to do inside that function is go into the input folder. I'm going to go to the input folder, load in memory every CSV file that I find in that input folder, add them up together. So that will be all of our data. And basically randomize or shuffle it. So whenever I make the splits, I make sure I don't have any weird order there. I'm going to shuffle all of the data. And that's it. I'm going to return a pandas data frame so I can later use it. That's what's going to happen within that folder right there. Let's go there. Okay, here it is. I'm setting up the directory here, pointing to the base directory /input. That's the folder that SageMaker is telling me that's what I'm going to copy the files. So that's why I'm referencing here. And then I'm going to sort of like create an array with the name of every CSV file within that folder. That's what I'm using the glob function here. That's basically going to list out all of the files within that folder. It's going to grab every single file with the extension CSV, and it's going to return the name. And I'm going to add all of those names into this array. Why is this important? Why is this something cool, like reading all of the CSV files? Well, we are starting right now with one file with the penguins data, but in the future, we expect scientists to go and collect more information, or people using our application are going to start sending more data about penguins. And we want to retrain our model. We want to rerun our pipeline that's going to go through the whole process. And the way to do that is to, okay, maybe we say every 100 samples, we're going to add a new file in S3. So we're going to have, files maybe dated by the week, by the month, or by the number of samples. And we want our pipeline to be able to load all of those files and process them, right? We can do that, or we can just always read a single file, but then we're going to have to edit that file with more data as we capture more data. It's easier to just add new files and have the processing job process them all. That's why I'm reading every single CSV file. Cool. If there are no files, I'm just going to raise an exception. This is going to read every one of those files, and this is going to concatenate them all in memory. It's basically a big data frame with the data from all the files. Finally, this is how you shuffle a data frame. It's a weird way. Let's call it sample. But anyway, what this is going to do is basically reorganize all of the data within this data frame. That's the read data from input CSV files. Very simple. So let's keep going down the line. This here is the definition of the target transformer. Target because this transformer will take care of transforming my target column. The target column is species. So if you remember from the session, we don't want to use categorical data to train our neural network. Neural networks do not work with categorical data. We have to encode that categorical data with numbers, basically turn strings into numbers. And the way I'm going to encode the target column or the species is using an ordinal encoder, which is very simple. It's basically going to replace each one of those strings with a consecutive number. So Adelie will get 0. It starts with 0. Then Bisco will get 1. Actually, Bisco is an island. Sorry, Adelie will get 0. Gentoo will get 1, and Chinstrap will get 3, or something like that. I don't remember the exact order. The important thing here is that every string will get replaced with a consecutive number, 0, 1, or 2. So I'm going to define this transformer here. I'm going to use that later. By the way, this is just a scikit-learn transformer. Scikit-learn has a bunch of these. That's what I'm going to be using here. Then I'm going to define a numeric transformer. I'm going to be using this numeric transformer to transform every numerical column. So I want to do two things to every numerical column. First, I'm going to be imputing missing values from the numerical column. So anytime I find a missing value, remember, we found missing values in the data. We didn't find any missing class. So the target is fine. We don't have to do any imputation, but we did find missing values in the columns. I want to impute those missing values using the mean or the average of the entire column. So for example, column length, if there is a missing value, I'm going to be computing the mean of the column, the whole average, and I'm going to be using that average to replace the missing value. That's a very common strategy. After I do that, I'm going to be scaling that column. Why am I doing scaling? So neural networks like to work with values that are approximately in the same range. So here, in this example, I'm going to scroll up to where we loaded the data so this makes sense. Look at this. The column length, it's 39, 39, 40, 36. So it's, let's say, between 0 and 50. That's sort of like the range of that column. The body mass, however, is in the multi-thousand. So it's 3,000, 3,700, 3,800, 3,200. So it's very large compared to the column length, which is very small. So without getting into the nitty-gritty details of that, a neural network will not like that, okay? And the reason is because of the weights, the way the multiplication with the weights work and the input features. If you feed a network those two columns with such a disparity, one of the columns, the one with the larger value, will become more important to the network. Why? Because the multiplication by 3,000 will be way larger than the multiplication by 37. So how do you fix that? Well, you scale every column and squeeze it within the same approximate range. That's what scaling and standardization do for you, okay? Again, there is way more to dive deeper into that and how they work, etc. But just know that that's what I'm doing here when I'm creating this pre-processing script. I'm basically standardizing every numerical column so they all go from the same range, right? So the ranges will be approximately -2 to +2, approximately, okay? It's just an approximation. I'm basically squeezing every value to have roughly the same scale, okay? The same range. All right, so after defining the numeric transformer, which by the way, I'm using the make pipeline function from scikit-learn. If you have not used scikit-learn pipelines before, you should, because they are really, really good. So after defining the numeric transformer, I'm going to define a transformer for the categorical columns, okay? We have the island, for example, which is a categorical column that we also need to transform. And first, I'm going to be imputing any missing islands by using the strategy that's most frequent. So it's going to go to the island column. It's going to say, hey, if you're missing, I'm going to replace you with whatever is the most frequent value in this column. That's a perfect valid way of imputing values. So that's the imputation. And then I'm going to be doing one-hot encoding. You probably saw, if you're not familiar with one-hot encoding, we talked about it in the first session. You should probably Google it. But basically what's going to happen here is that it's going to replace my island column with 3 more columns. And each one of those 3 columns will correspond to a potential value of the island. So we have 3 islands. We have Dream, Bisco, and Torgerson. So there are going to be 3 columns: Island, Dream, Island, Bisco, Island, Torgerson. And each one of these columns is going to be either 0 or 1, depending on whether that particular sample belongs to that island. So for example, you could get 100 or 010 or 001 for each specific column. We saw why during class, but this is another way to encode a categorical column into numbers because our neural network needs numbers. Okay, so now I have a numeric transformer. Now I have a categorical transformer. I need to put them together into sort of like a larger pipeline, a larger transformer that will direct scikit-learn to which columns apply which transformer. So that's what the features transformer looks like. So here I have the target transformer and the features transformer. And this is just putting everything together. The features transformer will say, apply the numeric transformer that we defined before to any column, every column of the data, except those that are object. And when you read a data frame, when you read this data in a pandas data frame, you will notice that the categorical columns will come through as object columns. So basically what I'm saying here is anything that is not categorical is going to be numeric. So apply the numeric transformer to every numeric column. And then I'm going to do the categorical transformer. I'm just applying it to island. This here is interesting, and I want sort of like you to think about this. There is another categorical column in this data set, and that is the sex column. But I'm not applying it. I'm not applying any transformers to it. Why? Well, because I don't need the sex column. The sex column is not important. And because it's not important, I'm just going to drop it from the data. I can train a model without showing it sex. That's what I realized. And the way I'm dropping it is by not specifying it as part of my column transformers. So when I run this transformer, because I'm not referencing the sex column, scikit-learn will ignore it, which is, I don't care about it. Okay, that's why I'm applying the categorical transformer only to the island column. If I say that just include, so I can use something like make column selector, the type include object here, but if I do that, it will include the sex column and it will apply the categorical transformer to the sex column, but I don't want that. Again, I'm just gonna ignore that column. Okay, cool. So I define my transformers now. I'm ready to apply the transformers, but remember, before you apply any transformations, you want to split your data first. That's what's gonna happen now. So here, I'm calling split data, passing the data frame, which contains all of my data, and I'm returning the 3 splits that we care about: the train split, the validation split, and the test split. Cool, let's see what split data does. So let's go there. I lost my mouse there for a second. Okay, very, very simple. I'm going to call the train test split scikit-learn function twice. I mentioned this during the class, but basically what I want to do here is 70% of my data I want to for training, okay? So the first line is creating df train with all of my train data and a temporal variable. And I'm assigning to this temporal variable that corresponds to test. I'm assigning 30%. So you'll see here that I'm saying that the size of the test will be 30%. So that means that 70% of my data will go here and 30% will go to temp. And that temp now I need to split in half because 50% of that 30% will go to validation and 50% will go to test. And that's what's happening right here. So now I have validation, I have test, and I'm rerunning this function, but now passing that 30%. And I'm saying split that 30% in half. So that's gonna be 50%. So in total, I'm gonna end up with 70% train, 50% validation, and 15% test. And I'm just returning the 3 sets at the end of this function. That simple. Cool. So I now have my data correctly split. This function here saves some baselines. I'm not gonna get into this function right now. You guys can check it out for yourself because we're not gonna use this function until session 5. And basically, just so you know, I'm saving the data before I transform it. And that's gonna be key in session 5, where we're gonna come back here and take a look at this. But just notice that what's happening here is I'm getting train and saving it to the hard drive as one of the outputs. It's gonna be called the train baseline. Again, session 5 will explain why. And I'm gonna do the same thing with test. So we're gonna get a test baseline in the output. That's what's happening here. Before I transform, I'm saving this data. Now it's time to transform. And I need to apply transformations to the target column. We have a target transformer, and transformations to all of the other columns, which we have a column transformer for that. I think we call it features transformer. So let's apply the transformation to the target column first. This is how it works. I'm gonna grab my target column, which I need to reshape and I need to do all of this. This is a NumPy plus pandas thingy, which I need to pass the data in a specific format for that transformer to work. So don't stress out about this. You can run this separately. You can see exactly what I'm returning. I'm doing a reshaping here so I can provide the data to the transformer in the shape that the transformer expects me to provide that data. Not a big deal. For you, I want you to understand that what this line is doing is going to the trained species column. You can see it here. Trained species values, and is transforming those into Y trained. Remember, the target transformer, what that is doing is applying an ordinal encoder to that column. Notice something that's very important. I'm using the fit transform function of that transformer. But notice that down here, when I apply the same transformer to the validation data, and then I apply the same transformer to the test data, I'm only using transform, not fit transform. Why is that? Well, very simple. The fit transform does two operations. First, it's going to fit our transformer to the trained data. Why the trained data? Because that's what I'm passing here. This is just my trained data. What fitting means is basically the transformer will compute all of the global statistics of the data that it's being fit on. In this case, of the trained species data. What are the global statistics? Well, this transformer needs to apply an ordinal encoder. So that means that it needs to know how many different values, different categories we have in the species, which are 3, and what are the names of those. That's the global, sort of like the global statistics that the fit is going to compute, okay? And the reason it's going to do that is because later on, whenever we apply that transformer, the transformer will use the global statistics that we fit it on to make those transformations. Because if we don't do that, for example, if we do fit transform here, and we do fit transform here, the ordinal encoder might change the order. So we might have ADELY 0, Chinstrap 2, and Gentoo 3, and when we apply it to the validation data, we want to make sure we use the same exact order that we used before and the same exact values. So Chinstrap is going to be 1 on every data set, right? So just to avoid from the fit transformer now to do something different, that's why we are going to first going to fit it, and then we're going to transform the data, okay? So that's what happened in these 3 lines. Again, we fit once, we transform everything else. That's even more important when we have more columns. And the global statistics will get a little bit more complex. We'll see that in a second. After I do this, what's happening right here is that I'm dropping the species column, okay? I'm getting rid of it. I don't need it anymore because I already transform it and store it in this Y variable. So I have Y train, Y validation, Y test. That stores the target column. By the way, it's common in the industry to use a Y, lowercase y, to specify the target column of data. So whenever you see Y, that means that's the target, right? And X, capital X, because there are usually multiple features, capital X is usually used to specify the features, the columns, right? Y for the target, X for the features. Okay, so let's drop that column now, just so our data frame, our DF train, DF validation, DF test, contain only the columns that now we're gonna need to transform. So let's do that here. Very simple. Same thing that we did before. We're gonna start, but now with the features transformer, obviously. We're gonna start by calling fit transform on the train data. Again, fit transform will do 2 operations. We'll fit the transformer to our data, will compute all of those global statistics from our data. In this particular case, the global statistics are a bit more complex, so we're using this as part of the features transformer. So notice that number 1, the simple imputer, needs the mean of the column, the average of the column. So the fit transform will compute the average of the whole column of our trained data, and we'll use that value anytime we call transform. So whenever we need to replace a missing value with the mean is gonna come from the original global statistic that we computed during fit. That's what's gonna happen here in this line right here, okay? So after we fit transform the train data and store the results in XTrain, we're gonna transform the validation data, we're gonna transform the test data. Very, very important that you always fit on the train data and transform the rest. And guess what? That's not it for the transformers. We're gonna need to use these transformers later on whenever we're ready to predict production data. That's why we have a safe model here. I'm gonna get there in a second. Before, these safe splits is now going to save our transformed splits in the hard drive. Remember, we need to spit out the output that we want this processing job to use. That's what safe splits is going to do. Let's go there. You'll see it's very simple. This is the safe splits data. And basically what I'm doing here is first, I'm putting all of the data together. Remember, now we have the X variables. They contain all of the features, and the Y variables contain the target. I'm gonna save a single file. I don't want to save them apart. So I'm gonna sort of like join them. I'm gonna get all of the features that have been transformed. I'm gonna get all of those features, and append, the final column is gonna be the target. So that's what's happening here. This is a NumPy concatenate function, and I'm concatenating the X train with all of the features with the Y train, which is the target column. And I'm doing the same for every one of the 3 files that I want to save. So every file will still be a single file for train, a single file for validation, single file for test, and we're gonna get all of the features plus the target column. This is just creating the folders where I'm gonna be saving every one of the files. So this defines the path, this creates the folders if they don't exist, and then this is saving. Notice that I'm turning, this is a NumPy array here, I'm using NumPy here, this is gonna be a NumPy array, turning that into a data frame and using the toCSV function to save those files. They're not gonna have a header and they're not gonna have an index. You have to specify that. If not, the data frame will create fake header. So they're not gonna have any of that. And that's it. That's what the safe split does. One more line that I mentioned within this script. Save model. Save model is going to save the target transformer and the feature transformer. Why? Because we need to use them later. Whenever we deploy our model, session 4, I think, we're gonna have to run production data through that model. And to run production data through that model, we first need to transform the data that's coming from clients, from customers. We need to transform it exactly like we transformed the train, the validation, and the test data, right? Because that's the type of data that our model will be expecting at that point. And we want to use exactly the same transformers that we used during this stage. If we use a different transformer, the results, the predictions are just gonna be wrong, are gonna be different. So we want to use exactly the same transformer. That's why I'm saving it here. Let's take a look at the save model function. Should be very simple as well. So I'm creating a temporal directory, and within that temporal directory, I'm using the job_lib dump function to save the 2 transformers here. And one I'm calling target.joblib, and that's the one for the target column, so I can later recognize them obviously. And one I'm calling features, and that's the one that's going to transform all of the features. These are the 2 ones. I'm saving them inside that temporal directory, and then I'm creating a /model. That's where the actual output will go. And what I'm doing is I'm creating a file that's called model.tar.gc. And this file, it's sort of like compressing together the two transformers. So instead of outputting two separate files, I'm outputting a single model.tar.gc file that contains both transformers later on. So you'll see whenever we're ready to use those, I think it's in session 3, session 4, you'll see how we're going to have to extract the model.tar.gc to access the two files inside. Cool, awesome. So again, this is our script. This is the script that we need to tell SageMaker to run in the cloud right now. When you run this line, notice that the output of the line is overriding code /. So nothing executed here. Remember, this is just a write file line. This is a line that's gonna be written to this file here. Okay, awesome. It's funny, I'm out of breath. For some reason, since I started this video, I've been out of breath. Not sure why, but if you see me out of breath, it's because I'm out of breath. All right. So what's happening now? Every time I write a script, I try to test it. I'm not big into TDD or anything like that. I don't want to be sort of like selling you on that idea, but I do try to write some unit tests to try to catch as many issues as I can before I actually run my code. So I'm using IPyTest here, which I mentioned is a great cell magic that I installed as part of your requirements file. And IPyTest will run PyTest unit tests right within the notebook. So anything here in this cell that starts, any function that starts with the test word is a unit test. That's the way PyTest works. So here I have one test, another test, another test, another test, so I have a bunch of tests, I think like 8 tests. And when I run this cell, when I execute this cell, every one of those functions is gonna be executed, and every one of those functions is going to test something. I'm not gonna go line by line, I'm gonna leave that to you. But for example, this function tests that every split is transformed. So I'm gonna go read the transform output and make sure what I'm getting out of that is the transform data. It's not the original data, but it's the transform data. This one here makes sure the baseline files are not transformed. This one makes sure that the baseline files include the header. Remember, I told you that I did not include a header in the split files, but the baseline requires a header. So this is sort of like testing for that. The train baseline includes header. Test baseline does not include header. So multiple tests, just making sure that I'm doing what I'm supposed to do. So check the tests out, and at least check out IPyTest is super cool. Okay, cool. So now we have a script. Now we are ready to set up the processing step. This is the thing that we've been waiting for. At least I've been waiting for it, right? Now we set up the processing step, and then we can define the pipeline, and we're done. It's very simple. So we are going to be using what SageMaker calls a processing step. Let me get back here really quick to this image. This is a processing job. And in a pipeline, when you are working on a pipeline, you access a processing job through a processing step. That's how you define it as part of the pipeline. So let's see how we do that. Before we get into the details of the processing step, I'm gonna define the caching configuration of my pipeline. Something super cool about pipelines is that you can cache individual steps of that pipeline. And the reason that's important is because when you run your pipeline, if SageMaker finds a previous run of a particular step that was successful within the time period defined by the cache, SageMaker will not rerun that step. Instead, SageMaker will reuse the result of that step. So it's going to save a ton of time because we're not going to have to run every step over and over and over. Instead, we are going to use the cached version. So here I'm defining the cache that I'm going to use for all of my steps. And you can use different cache configurations for your steps depending on what you're building. Here I'm just using a cache here that's going to expire after 15 days. So if I run a processing job today and it's successful, and tomorrow I try to run it again, it's not going to run. Basically, SageMaker is going to reuse, if nothing else has changed, SageMaker will reuse the result of the processing job that I ran today. Why? Because it's being cached. But if I run it in 16 days from now, SageMaker is going to say, nope, it's outside of the 15-day period, so I'm going to rerun it again. That's the way caching works. In a real application, caching saves a ton of money, okay? Caching is very important because you don't want to be running all of these processes if you don't have to. So for example, let's say you schedule your pipeline to run every day, but you only want the pipeline to actually run if you have new data. If there is no new data, you don't want the pipeline to run again. So you can cache it, and every day you're still gonna run the pipeline, but if no new data has come in, pipeline will not actually run anything. It will basically reuse every single output. It will produce the same outputs that it did the time before. So it's very important, caching. And you can read more here. Again, it's just the documentation. You can click that and it will take you to the documentation of the caching step. All right, so defining caching there, gonna define something else that I need, and it's a parameter. It's a pipeline parameter. These are critical. These are very important. The reason they're really important is because they let us create pipelines that are very flexible and that we can configure to do different things. For example, this parameter defines the location of the data that we want our pipeline to process. You'll see that in a second how I'm using this parameter. But think about this. Right now, I'm going to be pointing my pipeline to this location, which is where you uploaded your data set during the setup instructions. But in a real application, you might have all of your data sitting somewhere, maybe 1 terabyte of data, many, many rows, but you don't want to test your pipeline with 1 terabyte of data. It will take a long time to process all of that data. So you may have a staging environment or a different folder in S3 with a few hundred samples. 1 terabyte of data, few hundred samples. And you can run your pipeline, same pipeline, without changing a single line of code by changing the value of the dataset location. By doing that, now you're pointing your pipeline to the staging area with a few hundred samples, so you can test your pipeline without touching the actual data. So it's very, very cool to have this flexibility. You don't have to go to the code and change your pipeline. You can just run the pipeline, passing a different value to a parameter. And you'll see in the UI, when I show you the SageMaker UI, how you can do this manually. It's very simple. So anyway, I'm defining this parameter that we are going to use as part of our pipeline. And now the good stuff starts. Let me take a sip of my drink here that I'm almost done. Okay, so we are creating a processing job. To run a processing job in SageMaker, to define a processing step in SageMaker, you first need to define a processor. Okay, that's the way they call it. And you'll see later what an estimator is in session 2, and you will see what a tuner is in session 2 as well. So they have all of these weird names for these classes. So for a processing job, we need a processor. The processor defines 3 very important things for SageMaker. First, it tells SageMaker which framework we want to use to run our script. okay? So in our case, if you look at our script, we are using scikit-learn. So we want to install a container in the cloud that supports scikit-learn. Why? Because we need access to that library. That's the framework that we're gonna be using. If we were using PyTorch to transform our data, we will need to run a processor that uses PyTorch. That's it. So that's the first thing that we're gonna define. What is the framework that we need? We also need to define what is the hardware that we need to run. Okay, so in this case, the hardware is gonna come, remember, from the instance type, this config here. Remember that we defined this as an ML M5 X large before. If we're running in SageMaker, this is gonna be an ML M5, okay? That's the type of hardware that SageMaker will provision to run this job. And obviously the correct value here will be depending on how much memory do you need to process the data. Do you need a GPU to do so? How many virtual CPUs, how fast they should be. That's sort of like the consideration to select a computing platform here. Something that I added here that's very important. Again, I already mentioned that by default, you won't have access to the ML M5 X large instances. If you get to this point and you still don't have access to them, session 1 you can run by using an ML T3 Medium, which you do have access to it because SageMaker will give you access to them. I'm not using them because they're very slow. So this entire job should take about 3 minutes to run. But if you use an ML T3 Medium, it will take about 15 minutes. So it's very, very cheap computer, very bad. So it's gonna take a long time. But as a patch, as a workaround, while you wait for SageMaker, for AWS to give you access to ML M5 X large, you could just copy this and use it here. Just comment this out and you can say, okay, just to run this while they give me access, you can set it up like this, and that will use that type of computer. That should work when you run this with local mode equals false. Again, just in the meantime, okay? If you already have access to the ML M5, you don't need to do this. You can just run it the way it was before, okay? Okay, so we specify, let me start from the beginning actually. I mentioned that you needed the framework, and this is what I'm specifying here. My processor, I'm creating a processor from this class, which is an out-of-the-box class that SageMaker SDK offers. It's called sklearn processor, SK from scikit-learn processor. And you're gonna find when you go to, actually, let me open this. Let's see what happens here. This is the scikit-learn processor class. You'll notice that this is scikit-learn frameworks. If I go to PyTorch, for example, you're gonna see that there is a PyTorch processor class. There's gonna be a TensorFlow processor class. So if I close this TensorFlow, there should be a TensorFlow processor class. It's right here, TensorFlow processor. So every framework, and just a bunch of frameworks that SageMaker supports. Here you have TensorFlow, Spark, Hugging Face, MXNet. So any framework you're using is probably gonna have a processor. And that's basically telling SageMaker, whenever you use one of those, you're basically telling SageMaker, please install a container in the cloud to run this job that contains, gives me access to those libraries. Now, what version do you need? That's why you use the framework version here. Framework version is 1.2-1. And again, here you can see there's one of these links where you will be able to see all of the available versions for that particular container. Here I'm using 1.2-1. That's it's gonna contain the version of scikit-learn that I need to run my code. Okay, so framework, which version do I want to use? What is the type of hardware that I need? How many instances do I need? We saw in class, well, maybe we didn't see this in class, but somewhere, and we're gonna talk about them right here, you can run these jobs in parallel. You can do, for example, data parallelism and run multiple of these jobs in parallel. And in fact, there is one assignment for session 1. One of the assignments is about configuring this to run in parallel, multiple instances. So here you specify how many instances, and in this case, it's just gonna be 1. I'm gonna specify the role that we loaded from the environment variables, and I'm gonna specify the session, which again comes from the config file, because remember, we're using either a local pipeline session or a regular pipeline session here. Cool. After I configure my processor, it's time to configure the processing step. So I added this graphic here, which I'm gonna open up here because I think it's a little bit easier to just see in here. Okay, so here is what I configure. That's gonna give you a better idea of how this processing step works. Okay, so this diagram that I put together will sort of like help you understand what's going on here. So remember, we have the data that's gonna be coming from S3. That's our original data set. And the processing step, which I'm calling the pre-processed data, that's the name that I'm giving it to this step. This processing step will transform and split the original data set. Okay, not in that order. It's gonna split first, then transform it. Okay, we already created a script, so we need to provide the script that the processing job will execute when it runs, and we already created that script. Now, when we configure this job or this step, you'll see how we specify that script. And the output of this step will be train and validation sets. That those train and validation sets will go to the next step in the pipeline that we're gonna work on session 2, which is the training step. And a bunch of other stuff that you saw that we are outputting, right? So we are saving also a test set, we're saving models, we're saving baselines. We'll see that in a sec. That's the other output here. Now this section down here shows you what the processing job looks like. And the processing job is what's going to happen behind the scenes. When we define our step, we add it to a pipeline and we start that pipeline, you will see the processing job. I mean, you will not see, but behind the scenes, there will be a processing job running. So the processing job, again, it's gonna take everything that's in S3 that we specify as an input, and it's gonna copy that over a processing container. This processing container is gonna happen in the cloud. There's gonna be an instance. In this case, I specified it here as an MLT3X large instance. It's just whatever hardware we're using. That instance is gonna have the container inside. There's gonna be an input directory. All of the data from S3 will be copied inside that input directory. Our script will run in this processing container. We need to save the data in the output directory, which we did. And then that output directory will automatically be uploaded to S3 by SageMaker. That's the way it works. Grabs the data from S3, copies that data in the processing container, runs our script, grabs the output, uploads the output back to S3. So that's what's gonna happen here. Notice that this is a cluster. We're just running one instance. If we were running multiple instances, all of them will be part of this cluster here. So during the assignment, when you have to configure multiple instances to run a processing job in parallel, what's gonna happen is that instead of having one instance, you're gonna have multiple of them, and the script will run in all of them. So that's sort of like the behind the scenes, this step. Let's go back to the code. And this is the definition of that step. And it's actually very simple. I mean, it's long, but it's very simple. So the processing step, this is the name. This is the name that we're gonna see. Whenever you see the pipeline, you'll see the name of every step of the pipeline. And the name is going to be pre-processed data. That's the name that I picked for this. And now I'm going to just notice that here I'm calling the run function of the processor that we just defined. Here is the processor that we just defined. And this is how I specify now all of the inputs and outputs and the code that the processor needs. I'm going to start with the code. I'm telling here SageMaker to use the script that we defined at the beginning of this session. So, hey, please run this, execute this script when you, in the cloud, when you run this job. The inputs, only one input. And that input is basically the source of the input. Where the data is coming from is the value of the parameter that we defined. Remember that we defined a parameter. Let's go up. Here's our parameter. And that parameter, by default, if nobody specifies otherwise, by default, it's just going to grab the data from the S3 location that we define in this notebook, inside /data, right? So if I go to my S3 location, this is where my S3 location is. Within data, there is a data.csv file. You should have this file as well on your S3 location. That's where the data is going to be coming from. That's where the pipeline is going to be, or the processing job is going to be looking at to grab the data. Okay, so we specify the code, we specify the input. Oh, by the way, the input, you specify two portions of it. So first is the source, which in this case is S3, and the destination. Where within the container am I gonna save this? And in my case, I'm saving it inside a folder that's called input, okay? And if you go back to the script, I'm not gonna do it right now, but if you go back to the script, you will see that that's the location where I'm reading all of the CSV files from. And right now we only have one CSV file, but again, in the future, we might have more than one. Cool, awesome. Now let's do the reverse process, which is defining the outputs, okay? So the first output here is gonna be called train. The source is in this folder, opt or optional/ml/processing/train. That's a folder that I created within my script, and inside I'm going to put, or my script is saving the train data. The destination of this, so where SageMaker is gonna save this script in the cloud, is gonna be in this destination. So this is S3 location /preprocessing/train. So if I go back to S3, after executing the pipeline, you will get this pre-processing folder, and inside you'll see there is a train folder, and inside there is the CSV. That's the split, the train split that was already transformed. That's the way it works. So I'm gonna define one output for train, one output for validation, one output for test. Then I have one output for the model. Remember that we're also saving the model, and we're gonna use that output later on. And I'm saving two more outputs. One is for the baseline, the train baseline, and one is for the test baseline. I notice that all of these outputs follow the same exact structure. There is a name, a source that refers to a local folder within that processing container, and a destination which refers to an S3 location where the data will be saved. And by the way, you don't have to specify a destination. If you don't, like if you get rid of this, SageMaker will save those files whatever it wants to save those files. It's gonna create a folder and save them there. Doesn't matter. I'm specifying them here so I know exactly where those files are, so I can go and check those files. A downside of doing that is that I cannot run this pipeline, two versions of this pipeline in parallel, because both instances of the pipeline will be trying to save the files in the same place. So if that is a problem for you, you must get rid of the destination and let SageMaker create a new destination for every run of the pipeline. I just keep that in mind. In this case, this is not a problem. That's what I'm doing. And the reason we need a name for the output is because when we connect all of the pieces later on, we're going to be using this name to point, to reference an output of a previous step as an input of the new step. So for example, when we train our model, you guys will see how we say the input of the training step is the output of the pre-processing step that we created before. And we're going to make that connection through the name of the output. It's going to be very, very cool. Cool. So final thing in this processing step is that I'm defining the caching configuration that we defined before. That's it. We're ready for the pipeline and see this thing running. So defining the pipeline, this is what it looks like. It's going to be called session 1 pipeline. So here you guys are going to see that I'm creating a different pipeline for every session, but every session is sort of like adding more. It's reusing stuff that we defined in the previous session and adding on top of it. But I'm separating the pipeline so that way when you run session 1 pipeline, you know exactly what you're going to get. You're only going to get one step. That's what I'm doing here. That's why I have a session 1 pipeline, session 2 pipeline, etc. So here is my session 1 pipeline. This is the name, parameters of this session. You'll see that in a minute. And obviously the parameter is the dataset location. You have to specify all of the supported parameters right here. What are the steps of this pipeline? Only one step, only a single step right now. That step is the pre-processing step. We only define one step for this pipeline. This is the configuration, which is something that SageMaker forces me to use. This is something that's pretty recent. Not a big deal. It's just whether it's going to use custom job prefixes or not. I just need to specify it. Here it is. Not a big deal. You don't have to worry about that. And the session that this pipeline is going to use that comes from the config. Again, remember, if we're running locally, this is going to use a local pipeline session. If you're running online, this is going to use a regular pipeline session. Final line, it upserts the pipeline. Upserting, horrible name. It's update and insert combined. So if it already exists, it updates the definition of the pipeline. If it doesn't exist, it's just going to insert the pipeline. Okay? So it's basically registering our pipeline so we can start executing it. That's the definition of it. Now let's run it. So this is the first blue cell that you're going to find here. So blue, just because I'm using the blue color, indicates I'm adding this big node to indicate that the cell below has one line that you have to comment out in order to run it. Why is that? Well, this line specifically starts the pipeline. So I don't want anybody to be running the pipeline, running this notebook and starting a bunch of pipelines and deploying models and doing all of that. Okay, so I don't want you guys to be able to do that without knowing that that's what's going to happen. So I added this cell magic here, this line. Basically what it does is prevents this cell from running. So I can execute this cell how many times, it doesn't matter how many times I run it, nothing is going to happen because this line here is preventing this cell from running. Okay, that's how I keep you safe from making stuff happen. So in order to run this line, you have to comment out that first line. You're going to notice that, again, whenever you see that blue node, it's just an indication that you have to do that. My suggestion is do that, run the cell, put it back the way it was so you don't forget. Okay. So how do we run up to this point? This is what I do. I want to run everything and then execute the pipeline. Remember, we're running in local mode, so everything that we're going to run is going to run on my computer right now. Right click on any cell, go to notebook cell, and do execute above cells. This is going to run every single cell above yours, the one you are standing on. And that's it. It's just going to execute every cell in order, which is great. So we are right here. Now I'm going to run my pipeline. So I'm going to Shift Enter. And this is running my pipeline locally, right here on my computer. Nothing is happening in the cloud, which is great. The reason nothing is happening in the cloud is because I'm running in local mode, and Session 1 pipeline supports local mode, which is awesome. So let's see it run. You'll see a bunch of logs. This is what you should be looking at. Right here, pipeline step, pre-processed data, succeeded. So that means that our job, our only step in our pipeline worked locally. Awesome. If I go right now to S3, again, no jobs were executed, but the data went up and down from S3 like we defined. If I go to S3 and I go, for example, here, train CSV, notice that when I opened this before, it was from yesterday. See, October 31st, today is November the 1st. I'm recording this on November the 1st. So if I refresh this, now you get November the 1st. So I just updated this 1:29 p.m. here, where I am, and I just updated this file. That was my pipeline that ran locally and saved a new train CSV file here in S3. Awesome. Let's run it now in the cloud. This is what needs to happen then. I'm going to go here and I'm going to go to local mode and I'm going to set it to false. So just by doing this, I'm basically telling SageMaker, do not simulate anything. Please create a processing job in the cloud and run this thing. Okay? So I'm going to go back to the cell that creates the pipeline. Remember, I'm going to run notebook cell. I don't know if you guys are seeing that, if that's coming through. That's probably getting cut off by my video here. Let me try to put it in a way that you guys can see that. Notebook cell, execute above cells. Okay, so now it comes across the video. So execute above cell. I'm gonna run that, and that's gonna run I made a change pretty early in the notebook, so I want to make sure I rerun every cell after making that change. So now I'm ready to go. Now you can see that the pipeline comes back after I upset it. It comes back with an Amazon resource name and everything. So this is the name of the pipeline in Amazon. So this is actually doing stuff in my Amazon account, in my AWS account. When I click start, I'm not gonna get any of these logs. Why? Because I'm not running this locally anymore. I'm just gonna get an indication that the pipeline is running online. So I'm gonna click start and there you have it. It's telling me this is a pipeline execution, yada, 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 yada. All right, so how do we know what's happening here? Well, you're gonna go to your SageMaker Studio, browser. Let's wait for this to open. Here it is. And within SageMaker Studio, you will find right here in the left menu, home, in the left menu, you're gonna find pipelines. And when you click there, you're gonna see, you should see in the list of pipelines, you should see session 1 pipeline. Obviously, I have all of the other sessions I've been executing, etc. But you will see session 1 pipeline because that's the one that we just created. If you go inside, now you see here that 53 seconds ago, my pipeline succeeded. It was really fast. That was because it was cached. Notice that before I ran 2 days ago, I ran the same pipeline. It took 4 minutes and 58 seconds. That's what you should expect the first time you run the pipeline, assuming you're using an ML M5 X large processor instance type. You should expect about 5 minutes of running time. If you're using an MLT3 X large, it should take about 15 minutes, maybe a little like 13, 14 minutes the first time you run it. The second time, it just took 2 seconds to realize, hey, this is cached, and we're gonna see that was cached. Double click on this. So if you double click on this line, that will take you to this execution, the one that we just created. So I'm gonna double click on it, and it's gonna load my pipeline. And right now, obviously, my pipeline contains a single step, which is the pre-processed data step. Obviously, as we add more steps, you're gonna see them all here. It's gonna get a little bit more complicated, but here is my pre-process step. Now you can click on that step and you can see everything you need to see. By the way, you're gonna see these steps in green if they succeed. You're gonna see them in red if they fail. This case is green, which is awesome. That means it ran. Click on the step and you're gonna see all of the inputs that we passed to this step. Some of those inputs are explicit, like we passed those specific inputs. Like for example, somewhere over there, we pass like the data. That's one of the inputs that we explicitly provided to this step. The script that we wanted to run, the step to run in the cloud, that's the preprocessor PY. Some of the inputs are automatically added by SageMaker. Some of these here, you can read them all. This is great to debug a processing job or a processing step in this case that ran in the cloud. If you need to debug it, if you need to understand what happened, why it didn't work, you will come here. Here you can see the outputs, and notice that here we have the 6 outputs that we define, right? We have the test baseline, the train baseline, the model, the test, the validation, the train. All of those outputs we specified one by one. You see logs, you see information here. Notice that if I go to the information, it says cache hit result, cache hit, and it tells you exactly what execution is taking over here, right? So we're getting the results from the cache. We're not rerunning it. If you make any changes to the code, if you make any changes to the input, obviously the cache will, it's gonna miss the cache and it's gonna re-execute the job. Okay, so that's awesome. Something else I promised you to show you, if you go back to the session 1 pipeline, you can manually execute now the pipeline. Now that it exists, now that you register that pipeline with that upsert call, you can click on create execution, and notice how this UI here is automatically populated by SageMaker, and it's giving me a dataset location here. This dataset location is the parameter that we specified, right? This is the parameter that we specify as part of the pipeline. So I could say, okay, I'm gonna, testing this. Actually, I cannot use this thingy here. That's fine, testing this. And I could pass another location in S3 with a different data set, maybe fewer samples, whatever. And I could run the same pipeline without changing a single line of code on new data. That's the importance of parameters. And there are assignments where you will need to use parameters to do different things. By the way, this is me showing you visually how to do this. You can also do it with code. You can start the pipeline. And I go back to the code here. So here you could start and you can pass different values for the parameters, and it's the same thing will happen. Okay, so that's it for session 1. What you have to do right now is take a look at the assignments, pick the assignments that are that you think are the easiest for you to finish, and try to finish as many of them as possible. Remember, you are gonna get as much out of this program as you put in. The more time you dedicate to the program, the more you're gonna get out of it. And it's usually not enough to see me explaining code. You have to try yourself. You have to try and stumble upon all of the problems that you will stumble upon as soon as you try to solve the class project or the assignments. Okay, so that's great. Thank you for watching, and I'll see you in the second code walkthrough.